Hi, my name's Joseph Busch. I'm sorry I can't be with you today, but I wanted to give you a brief presentation on my topic, taxonomies for programming. Taxonomies in this context. We're talking about enterprise taxonomy. That's ones that are relevant to the entire organization, as opposed to ones that might be applied to a particular information management system. They're an enterprise taxonomy in the sense that they reflect overall program goals of the organization or strategy. They primarily function as in some sort of integrative fashion to bring together and organize and find and present information across disparate systems. And finally, they provide a common way and a framework to measure and report on performance. The objectives of such an enterprise taxonomy might be to comply with regulations if you're in a business like finance or pharmaceuticals, to measure and optimize performance if you're in commerce, that's to optimize the ability to get people to purchase and to purchase more. If you're in a more information management environment, to be able to find and use content, or generally to provide operations procedures to support operations. Now, taxonomy actually is very important. It's the glue behind metadata. So information assets are very expensive to create, so it's critical that they can be found for one particular reason, and that's that they can be used and reused. Every time you reuse a content item, the cost of creating that item decreases. If you reuse content, you actually increase the value of the asset. This is a notion that we might call metadata capital, and Dr. Jane Greenberg, who's organized this panel, has been using this term, and I think it's very apt. So content use and reuse reduces cost and creates capital. Let's call it metadata. What are some kind of performance indicators that we might associate with a taxonomy? Well, we might measure the number of assets that are produced or added or edited. We might look at how many are used. We might look at transactions associated with those assets. We might look at the quality of those assets in terms of completeness and consistency. We might look at the number of times assets are used. We might look at relationships or links that are built between assets, some sort of linking economy. We might look at how many responses or comments or feedback or subscriptions or service activities that are associated with a content item. We might look at changes. How dynamic has this environment been, and how quickly have we handled those changes? How many products or applications have been built or introduced during the period? And how many interactions have been associated with them? And then finally, we might look at some sort of satisfaction based on but enterprise taxonomy. We're usually talking about a high-level framework, not necessarily the detailed one intended to provide support for a particular detailed subject matter expert. So for example, if we're building a taxonomy for NASA, we want to look at something that's going to be associated with the organization overall from a strategic performance management and operational procedural perspective, not necessarily to support a particular activity like running a particular mission or putting a particular platform into space. So when we talk about enterprise taxonomy, we're talking about something that's broad and shallow, something like 8 to 12 facets or discrete divisions, 2 to 3 levels deep, no more than 20 categories per level, maybe 1,500 categories total. Now, there might be, in addition to that, many other terms, phrases, and information associated with the taxonomy, such as synonyms, abbreviations, translations, variations, and information that explains how that term or terms. An enterprise taxonomy standardizes things like product nomenclature in a scheme usually of 3 levels: category, subcategory, product. For complicated products, it might be model, system, and subsystem. I've been doing some work with very large industrial equipment. When we look at that equipment, the ability to understand what the major components of it are, particularly when you've got multiple instances of this equipment located at different sites around the world, becomes critical to being able to, for example, provide field support. It also standardizes the function or purpose of a content item in a records management context. It provides standardization of types of resources. One example of this would be the Darwin Information Typing Architecture, or DITA, that's was proposed by IBM and is a a best practice in the technical documentation community. That defines three broad types of resources. Resources that are associated with tasks or procedures, concepts, definitions, rules, and guidelines, or policies, and reference resources, which would be detailed factual material, such as user guides, manuals, and things like that. You want to, the enterprise taxonomy will standardize things like geographic locations and particular sites associated with those locations. And it'll also standardize things like business roles, things like employee, manager, partner, supplier. And quickly, I just want to give you three quick case studies. One is for the Bank for International Settlements. That's one of the international banking organizations that sets policies, so-called Basel I, II, and III. They're bankers to countries, so sovereign banking, if you will. And we worked with them a couple of years ago to develop a knowledge management categorization strategy, establish metrics to evaluate existing vocabularies according to some criteria, and looked at identifying vocabulary needs and built out a prototype that had these broad divisions in the enterprise taxonomy that we see above. This new strategy facilitates grouping of items, and it was very similar to the way in which documents actually were titled and labeled in the document management context based on routine processes, projects, and events. Example is more of a classic intranet. This was one for a large international company based here in Montreal, SNC-Lavalin. Their intranet is called the InfoZone, and we worked with them to help them develop a framework which has the major components that are identified above. The framework also incorporated some governance structure, and it was implemented in a SharePoint environment, which is very common in many organizations these days. The intranet was, the success of this project was primarily focused on improving search results across information sources, so you could discover, for example, training materials that you may not be aware of, but that might be relevant to the area in which you work. And the goal was to avoid recreating content that was already in existence. So one of these, reduce cost and increase metadata capture. A case study about a global health and beauty products company. This is a classic master data management problem. We helped them, we wanted to define a standard language to enable data sharing across applications, whether it was for logistics, for manufacturing, for sales and marketing. All of them needed to share information. So we came up with a common framework based on the shopkeeping units or SKUs, business processes, and other elements. And defined a faceted taxonomy that provided a constellation of information around a particular asset, in this case, a SKU. And it was a much more flexible design where every item of information or product would be described by a combination of facets. We focused on facets that applied to all products or to all products within large groups, and it provided the basis for general data management modeling across the enterprise. Talk to you about today some ideas about how taxonomy is important and can be manifested as a way of framing broad programmatic goals within an organization, and in particular, create value by decreasing costs and increasing value through metadata capital. Thanks very much. Please send me emails if you have questions. I'm sure the folks on the panel will be able to answer them or give you insights as well.